This is the final video from 2.2, and it's all about determining if a distribution is approximately normal using a graph or numerical evidence. So let's look at the unemployment rates from 50 states. So the first thing you can do is you can plot the data, which you can see that I've already done, so you don't need to do it. I've got a histogram showing, and you're just going to look. Does it look normal? Does it look symmetric? So it's unimodal, and it looks approximately symmetric, so that's a good start. But if it is normal, we'll know that it's going to follow the 68, 95, 99.7 rule. So if it follows this rule, which also may be called the empirical rule, then we can say it's approximately normal. So what I've done, and what I'm never going to ask you to do, but what I want you to know is an option, is that you can find the mean and the standard deviation, which I'm going to give to you here. The mean is 8.682, and the standard deviation is 2.225. So using this mean and standard deviation, I could figure out what's the range for within one standard deviation. And I can figure out what's the range within two standard deviations of the mean. And so I've done that here. And now all I'm going to do is I'm going to count what proportion are within one standard deviation. So I would count through, which I've already done. I'm not going to ask you to do. And I found that 36 out of the 50 states are in this range, -1 and +1 standard deviation from the mean. So calculate that out, and that is 72%. So it's not perfectly 68, but it's kind of close. And in this 2 standard deviation range, there are 48 out of 50 states, which is 96%. And then finally, within 3 is all 50 states, so 100%. So although it's not perfectly 68, 95, 90.7, this is pretty close to what the normal distribution looks like. So this isn't a great way, but it is one way to get evidence. The best way is what's called a normal probability plot. Normal probability plot is very simple, except you're going to have to type in all of the data. So I'm going to type all of this in list 1 in my calculator, and then I will show you how to find the normal probability plot. Okay, so I finished typing all of these 50 states unemployment rates into list 1. Now what I need to do is turn my stat plot on. So second y equals, go into my first stat plot, turn it on. And here's a scatter plot, here's a histogram, box plot. We want the last one. This is a normal probability plot. Make sure we're using list 1. And then the best fit, of course, is going to be zoom 9, and this will show me my normal probability plot. A normal probability plot, what you want to look for is the relationship linear? Does this look like it follows a linear pattern? And the answer is yes, this looks quite linear, which means this distribution is approximately normal. So let me pull up my notes again. So a normal probability plot, which you will never have to calculate this. You'll just have to do it the way I just did on my calculator. What it shows us is it shows us paired data, and the paired data is, it's your value, it's the unemployment rate with its expected z-score. You can see this was the graph that you just saw in the calculator. It's the unemployment rate showed against the expected z-score, and the outliers are going to appear as points that are far away from the overall pattern, like you can see this one here and this one out here. But the overall pattern here is linear, so it means the distribution is approximately normal or roughly normal. If there's no linear pattern, then it suggests that it's a non-normal distribution. So go ahead and on your own, you can type in this data, make sure you can see a normal probability plot. And just so you know, it will and should look something like this in your calculator. So that's the other thing I wanted to say is, after I've typed all of these values into my calculator, I can make a histogram and make sure it looks approximately normal, and also check with a normal probability plot.